Hey guys, we're going to work a couple more problems from page 49 as more examples of these sinusoidal word problems. Okay, so I'm going to look at problem 1 first, and this problem is about the Ferris wheel. You climb on the Ferris wheel and it takes you 3 seconds to get to the top at 43 feet, and you complete a revolution every 8 seconds. The wheel has a diameter of 40 feet. So our goal here is really to be able to write the equation for this, and because it can be difficult to understand these, I suggest just draw a picture to help you visualize what's going on. So here is my Ferris wheel, right? And when I'm at this high point, I'm up at 43 feet, and the wheel has a diameter of 40 feet. Okay, so if I go down 40 feet, I will be at 3 feet. Okay, now why are we not hitting the ground, guys? Because your Ferris wheel has to be off the ground in order to turn. Okay, now I figured out my max and my min values, right? And I can kind of say, if I pin my wheel in the middle, that center should be at 23 feet. Okay, and you can just say, hey, my radius is equal to 20 feet because my diameter was 40 feet. All right, so that's all information from the problem. Let's see what else we can learn from this. We know that it takes us 8 seconds to go around and complete a revolution. Well, completing a revolution, that's like my period. And what else can we learn? You reach the top at 3 seconds. Okay, so they said, hey, t is the number of seconds since the Ferris wheel starts. At 3 seconds, you're on the Ferris wheel, and boom, you're at the top. Okay, so we have the very first point that we're going to put together for our graph at 3,43. That is my first max. Okay, and my next maximum point, my second maximum point, will be 8 seconds later, and we will have 11:43. Okay. So the reason this is my second maximum is because that is the 8 seconds that we added on there. Okay, a full circle. So I've got 2 points right now. We've got 3:43 and 11:43. Let's see if we can try to sketch up a graph for this now. So here's kind of my x and y axis. I've got 2 high points right now. I've got my first point right here, 3:43, and another one over here at 11:43. Now remember, our graph isn't perfect. We're just trying to get as much information on here as possible. Well, we of course need some more content to help us fill this in. So let's think about where we should put another point. Well, if these are both maximums, halfway between, I've got to have a minimum, right? And earlier, when we drew our picture, we said, hey, I have a maximum at 43 and a minimum at 3 feet. So I've got a point down here that is something 3. So what number should we put there? We've got to be able to figure out the halfway point between 3 and 11. And to find this halfway point, all we have to do is say, hey, 3 plus 11, and then we'll divide it by 2. And you should get 7 for this number, right? And that's going to be my mid value. All right. Now that we've gotten that point, we can connect our dots together to come up with our wave, and we'll use this to help us make a equation. Okay, and now I'm going to just kind of put a little dotted line to show you that the wave is continuing this way. Awesome. Okay, so we're going to use the old school DA-BC method that we used for all our graphs. Okay, so we need to find DA, B, and C, and then we can write a equation for this. So the first thing we need to figure out is the D value. And D is going to be our line through the middle, right? That height right there. And we could calculate it out mathematically. We've actually already done it on our little diagram of the Ferris wheel, but just in case we didn't, if you're not sure what's halfway between 43 and 3, you do 43 plus 3 divided by 2, and you should get that this is 23. And that's going to be my D value. So here's 23, and we'll just go ahead and say that, yeah, my D is 23. Awesome. So let's go ahead and go to our next number, right? We need to figure out what A is going to be. And we can find A, which is our amplitude, from the graph, let's say, from this peak to the midline. And so if I say I start at 23 and I'm going up to 43, we should figure out that A is 20. Right? So we should find that. We can subtract to do that, guys. 43 minus 23 is 20. All right. Now for some of the trickier bits, okay? We want to calculate B. So B, remember, we can do 2 pi over the period to get my B value. Well, what's the period for this graph? That's right, we said it earlier. It's actually 8 seconds, like we said right there. And that's just the time it took to complete a full revolution. So let's just plug that in, 2 pi over 8, or just pi over 4. Awesome. Now we've got B, which is pi over 4. Okay, and from here we'll be able to calculate that last number, which is C. Okay, so C, again, that's going to be the first point for our graph. And I'm just going to use this 343 point, which is a maximum, which means we have to use cosine. Okay, so max at 3, so we use cosine. Okay, remember, if you had a midpoint that you were going to use, we could use sine, but we don't actually know any of the midpoints, right? I can kind of mark them on here, but we don't have numbers for them. Like these midpoints that I've kind of highlighted in yellow, we don't know any of the numbers, so we can't write a sine equation. So for my phase shift, my C, I'm going to say it's going to go from 0 to 3, right, to the right. So we can say C is 3, and I'm just going to say that it's going to the right as well. All right, so now that we've gotten A, B, C, and D, we'll be able to come up with an equation for this. And just like we said, it's going to be a cosine equation. So we've got y equals A 20 cosine, and I like putting parentheses around my B value as well. Pi over 4, parentheses x minus 3, right? That's going to the right. And we're going up 23, so plus 23. And that right there is going to be your full equation for this problem, okay? And we could do some calculations with this if we had a calculator, but we're just going to leave it the way it is, okay? Guys, this is how we solve these problems, okay? We came up with 2 maximums by using the first point, 343, and then adding the period to it. And we figured out what our high points and our midpoints and our low points were by drawing a picture to help us justify this, okay? Once you have that graph drawn, you can very easily come up with the DABC and solve this question. All right. Another example that we can do on here is number 3, okay, which is talking about an oil well jack. Okay, if you're not sure what that is, please go ahead, take a second, Google it. And just so you can have an idea of, hey, what's going on here, okay? So the jack on an oil well is going up and down, it's pumping oil, and at time 1 second, we're at a maximum distance of 3.7. So I'm going to go ahead and start making a note about this because I've already got 1 point. That's 1 second and 3.7 meters. Okay, and at time 4 seconds, we're at 1.5 meters. Now let's just note this first point was my max, right? And this is my minimum. All right, and they're saying nothing else. They just said, hey, sketch a graph and come up with an equation for this. All right, so let's think through how we can put this together. So let's start by drawing a little graphing and mark these 2 points on there. So here's 1, 3.7. And my next point is at 4, 1.5. All right, so how am I going to come up with a third point, right? I should be able to come up with either some kind of minimum or maximum. I just need a third point, really, to be able to graph this. Well, let's just start drawing this graph, and then I'm going to just see if we can find that third point. So I'll just start at our maximum, and we're going to kind of go down to the minimum, and it's, of course, going to have to turn back around and come up to another maximum, okay? And then my graph would, of course, continue downwards, so on and so forth. And on this end, it's going downwards again as well. All right, so we've got some kind of wave. I just need to figure out another point. And the most convenient one I can see here is this point right there, okay? That is another maximum. Well, the easy part about this is actually the y value's got to be 3.7. It's the maximum, okay? But how do I figure out what time that is? Well, this first section from 1 to 4 is your downward trend, right? Like we went down from 1 to 4. So coming back up is going to have to be the same time that we took going down. Now, what this means is we can say, hey, from 1 to 4 seconds, you went down. So that's 3 seconds total, right? So from 4 to 7, you have to go back up, right? 3 seconds each way. So that is each way. So now this point needs to be at 7. And voila, now I have all the information I can need for this graph. So what method are we going to use now to write our equation? Okay, same thing as before, D, A, B, and C. The DAB method, okay? And we're going to start with D. Let's draw our line through the middle and see if we can figure out where exactly this is. All right, so somewhere right about here. Dotted line. And we want to figure out what that mid value is, okay? So D, we can just say, hey, 3.7 and 1.5. We'll just divide it by 2, okay? And when we do this, we should get 2.6. All right, so D equals 2.6. Cool. We've got D. Let's go ahead and find our next value. That's going to be A. Remember, A is my amplitude. And we can just say going from my D value, which was 2.6, all the way up to my maximum. So we can say A is 3.7 minus 2.6, and you should get 1.1. So that's going to be my A value. And now we've got to calculate the B value, okay? So you'll remember B, we used the period to calculate B, but what's the period for this function? Okay, I'm hoping that you got to the idea that hey, my period is going to be from this maximum to this maximum, right? So my period is from 1 to 7, so it's going to be 6 seconds, okay? So my b value is 2 pi over 6, which is just going to be pi over 3. All right, so we've got b, now we finally just need c. Now, again, do I have a midpoint? Nope, so I'm going to have to use cosine to write this equation, okay? So, again, max point means cosine. All right, and here's the first maximum I've got at 1, 3.7. So I'm going to say this is shifted 1 to the right. And that's going to be my C value. Just 1, and it's going to be to the right. So now that we've gotten A, B, C, and D, all of them together, let's put it together and get our equation, okay? So again, it's a cosine equation. So we've got y equals 1.1 cosine, again, I like to put those parentheses in there, pi over 3, parentheses, x minus 1, and plus 2.6. All right, and that's your equation, assuming that x is your time and y is your height. All right, and again, we could plug the numbers in from part C and D if we were using a calculator, and we could figure out the heights and the distances and the times based on that. But for what we really want to do right now, we just want to be able to write these equations, okay? Once again, we're using that DABC method once we have a graph, right? We just have to think through, hey, what are my min and max points? Can I draw my curve? Can I fill in the information with better points, right? Again, I didn't have midpoints, so I couldn't write a sine function. I had to write a cosine. All right, I'm hoping this video gave you some insight about these problems and will help you set up your other practice problems of this nature. All right, good luck.